Hello, my little mathematicians. Today we're going to visually show how to multiply fractions. Okay, so first off, look at that question up at the top. So when you multiply a fraction by another fraction, what do you think? Will the product be larger or smaller than or equal to the original fractions that you started with, the factors that you're multiplying? What do you think? Is your answer going to be bigger, smaller, or equal to? Okay, so hopefully you put that it's going to be smaller. And if not, let me kind of show you why. So essentially, you're cutting a piece of something, because if you start with a fraction, that's a piece of something, right? It's not a full something. And then you're cutting that piece into smaller pieces because you're multiplying it by other pieces. So like, let's say you had a half, okay? So here's a pizza and you have a half left. Okay, so that's all you have. And then you're multiplying it by another half. So cut that in half. So how much is that? It's smaller than what you started with, right? It's only a fourth of the whole overall pizza. So first of all, we cut our whole into a half because that's what we started with. And then we colored it in because we're focused on this is what I had to start with. And then I cut the whole thing in half, and then that's what I have. I have one of 1, 2, 3, 4 pieces. Okay, so we're going to use that type of logic to help us visualize what's happening when we're multiplying fractions. So let's go ahead and take a look at this first one. And we're first of all just going to start with, let's picture what we have, okay? So let's say that this is a wall and we want to just paint 1/3 of it, okay? So they're getting all artsy on us and they don't want to paint the whole thing. They just want to paint a third. So here's my whole wall and I cut it into 3 pieces because the denominator is how many pieces you're cutting your thing into. The numerator is then how many of those pieces you have, okay? So like essentially, if it were up to me, you would shade the center, right? Because if you're painting a wall. But to make it easier, since it's a math problem, let's just shade right here. Okay, so this is 1, 2, 3 pieces. We shaded one of those 3 pieces. So this is what we have to start with. Okay, so let's have you go ahead and practice just shading the things that you start with. So what would 1/5 of a wall look like? Okay, how many pieces? 5 pieces, because that's what the denominator is. So 2, 3, 4, 5, and we're imagining that these are perfectly all the same size, right? Yeah, don't criticize. Okay, so they're all perfectly even 5 equal pieces, right? And how many equal pieces? We want only one of those 5 equal pieces to be colored, okay? What about the next one? Okay, well, your denominator is 3 again. So let's cut it into 3 pieces. And how many of those 3 pieces do they want? Hopefully you said 2, because the numerator tells you how many of those pieces they want, okay? Now, hopefully we've caught on. So what would the next one look like? Okay, you cut it into 4 pieces. I like to cut, if it's an even number, I cut it in half. And then I cut each of those halves in halves. And that makes it at least somewhat more even. Okay, now that's 4 equal pieces, right? Now, how many of those equal pieces am I going to shade? 3, because that's what the numerator is. Okay, so you have 1, 2, 3 of those 4 equal size pieces. Okay, if you haven't gotten any right yet, this is your chance. This is your moment. How many pieces are you going to break this one into? Yes, hopefully you said 5. Okay, so go ahead and do that. 1, 2, 3, 4, 5. Oof, I hope yours looks more even than mine does. Okay, so you have 5 pieces, and then you're going to shade how many of them? 3 of them. 1, 2, 3 of those 5 pieces. Okay, so this is how much you start with. This is how much you start with. That's how much you start with. That's how much you start with. And that's how much you start with. Okay, let's get a little bit trickier. So if we look at this problem right here, okay, it says look back at number 1 from page 1. Okay, so that was this one. You had 1/3, right? And they're saying build your Play-Doh. And you're like, what does that mean? Well, if we had Play-Doh, like before you felt comfortable actually drawing it, maybe you can want to try to manipulate Play-Doh and then cut it into pieces, but we skipped a step because you're smarter than that. Okay, so right here, how do you show 1/3? Okay, well, we already did it on the other page, right? You showed 1, 2, 3 pieces, and then you're shading one of those 3 pieces. Okay, so here's the 1/3 that's shaded. Okay, what if on the first day, so like this is how much you want to paint. You want to paint 1/3 of the wall, but you only painted half of that amount that you want to paint. What fraction of the wall did you paint then? So you want to paint 1/3, but you only painted half of the amount that you're supposed to. How much of the wall did you paint? What do you think? Okay, I want you to try to see. Okay. Well, let's go ahead and cut it in half. Okay. So that means that this is the only part that actually got done on that first day, right? So what does that represent? Well, how many equal pieces is the whole thing divided into? Not 3. How many? 1, 2, 3, 4, 5, 6 pieces. What fraction did you paint? So the pink highlighted part, what fractional amount is that? It's 1 out of 6 pieces. Okay, so write out what you painted in words. So you painted half of 1/3. So you painted this half of 1/3, which was 1/6 of the entire wall. Okay. So did your overall amount end up getting smaller or bigger than what you started with? Well, you started with 1/3 and then you only did half of that, and then you ended up with 1/6, right? So a half is here, a third is here, and you ended with 1/6 because you're doing half of 1/3. So when you multiply 2 fractions, you end up getting a smaller amount than each of those factors. Okay, let's visualize another one. So it says, look back at number 2. Number 2 was you were starting with 1/5 on the other page. So let's draw 5 pieces. 1, 2, 3, 4, 5. Okay, and you had, or your goal is to have 1/5 of the wall painted. Okay, but that first day you just didn't have that much time, so you only did half of the amount that you're supposed to. So then that means, okay, after the end of the first day, how much of the whole wall did you actually paint? Okay, well, to help us answer this, how many equal pieces is the whole entire wall divided into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Okay, what part of the wall did you paint? You painted 1 out of 10 pieces. And why did that happen? Because you only painted half of 1/5, right? Because this is how much you want. You want 1/5. Okay, 1, 2, 3, 4, 5 equal pieces. You want to have 1 of those 5 pieces colored, but you only did half of that amount on the first day. So how much of the whole wall did you paint? You painted 1/10 because it's broken up into 10 pieces and you only shaded 1 of the 10. Okay, hopefully you've caught on a little bit. So let's make it a little bit more tricky. Okay. So if you look back at question 3, it says that we started with 2/3. So break your wall into thirds, and your goal is to have 2/3 of that wall painted. But on that first day, you only do half of the amount that you're supposed to. So then how much of the whole wall did you end up painting? What do you think? Well, you have 1, 2, 3, 4, 5, 6 pieces. You painted 1, 2 of those 6 pieces because you only shaded half of the 1, 2, 3s total, and you 1, 2 is how much you want. So you painted half of the 2/3 you wanted painted, which equals 2, 6. So when you got your answer, you kind of seen like how the factors relate to the answer you get. If not, we'll show it at the end. We'll reveal it. But here's a visualization of what's happening. Okay, let's try another one. Okay, if we turn the page, this one says back at number 4, we started with 3/4. So for 3/4, let's go ahead and draw that. I cut it in half, and then each of those halves in halves, and 1, 2, 3 of those 4 equal pieces. Okay, so the whole wall is divided into 4 pieces. And then we only painted half of that amount, which is right here. So what amount of the overall wall did we do? Well, we did 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8 pieces. Because we painted half of, we started with 3/4, right? And then we ended with 3/8. All right. Now we have this one. This one looks more square-like, huh? It says, for each problem below, draw a picture to show the areas as the product of the factors on the square, so it's a square, not a rectangle this time, has a length of 1 by 1. Okay, so I think it's easier to cut it in half. So let's start with 1/4. So let's cut this into fourths. Okay, and then you're starting with 1/4. And then you only painted half of that amount. So we need to cut each of the boxes in half. So then what does that end up equaling? Okay, so again, we did half of a fourth because we cut it into 4 pieces, and then we cut each of those 4 pieces in half as well. Okay, so how many equal pieces is the whole thing divided into? 1, 2, 3, 4, 5, 6, 7, 8 pieces. What fraction of the whole represents the area or the answer, the product? Right here, 1 of those 8 pieces. So that means that 1/4 times 1/2 is 1/8. Okay, why don't you try this one? It's easier probably if you start with this and then cut each of those in half. So start with 1/5. So I could do this way, or I'm going to do this way. 1, 2, 3, 5, 1, 2, 3, 4, 5 equal pieces. Okay, so you want to start with 1/5. So there's 1/5. And then you only painted half of that amount. Okay, so this is representing the amount you actually got done on the first day. So what's happening is you want to find half of 1/5. So how many equal parts is the whole divided into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you cut it into 5s and you doubled the amount, so 10. Okay, what fraction of the whole represents the area or product? 1 out of 10 total pieces. So half times 1/5 is 1/10. Do you notice what's happening each time? Look at the numerators. 1 times 1 is 1. 2 times 5 is 10. 1 times 1 is 1. 4 times 2 is 8. 1 times 3 is 3. 2 times 4 is 8. So that's what's happening with each of these when we multiply. You multiply across the numerators and you multiply across with the denominators. But here's a visualization of why it's working that way. And then do they get tougher than that? Yeah, so here's some tougher ones if you were curious. So it says you have 1/3 times 1/4. So I cut it into thirds, okay, and you have 1/3. And then I cut those into 4 pieces, and then you want 1 of those 4 pieces. So that's 1 out of now 12 individual sizes. So yeah, they can definitely get more complicated. We just started with multiplying them always by a half. And then even more so, what if, let's say we started with 2/3. So I cut it into thirds, okay, 1, 2, 3 equal slices. And I shaded 1, 2 of those 3 equal rows. And then you want to cut those into thirds. So I cut them into thirds this way. And you only want 1 of those 3 pieces. So that's right here, which is 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9 equal pieces. So you can see as it gets more complicated, yeah, the shading does get a little bit more complicated too. But at the same time, it's definitely doable. You can feel free to like write the original problems down, try to draw it yourself, pause the video, and then come back and check yourself with these. And if you can master these drawings, dude, you can master anything. But for the most part, we're going to, after this, just do it mathematically. So multiply the numerators. 2 times 1 is 2. 3 times 3 is 9. 1 times 3 is 3. 3 times 4 is 12. Okay. But at the same time, if you want to visualize it and see why it's happening that way, here's how it works. All right. And congratulations, my little mathematicians. Hopefully now you understand why our answers work out the way that they do when we're multiplying fractions.